You know how sometimes in life things don't go exactly like you hope? You thought they were going to turn out one way and then they end up turning out totally different, or maybe not totally different, but similar, but not quite what you want? Well, that's what we are going to talk about today in chemistry. In our last podcast, we learned how to predict how much product we're going to get out of a reaction based on the amount of reactants. That sounds great on paper, but the reality is when we do that reaction in the lab, we may not actually get that amount of product that we thought. There may be a difference, and that's what we're going to talk about today, percent yield. Looking at how what we thought we should have got compares to what we actually got. Okay, to do percent yield, we have to have some basic assumptions. First of all, we're only looking at one reaction. There's no other side reactions that spin off that may reduce our product. There's only one reaction that's involved. So we ignore any other reactions that may be going on. Secondly, all the reactant that we start with is going to be converted into a product. There's none of the reactants left over. There's no extra. Third, we assume that we collect all the product, that none of it escaped, that we didn't accidentally spill it, anything like that. So all the product is collected. And finally, we assume that things just don't go wrong. Things work as they're supposed to. But like I said, in the real world, we know that always doesn't happen. Okay, we should talk about yield. Yield means how much did you get off. And there's two types. There's what we call the theoretical yield. This is when we use an equation using stoichiometry to figure out how much of the product should be produced. We start with X grams of a reactant, we should get this much product out. We do that using the stoichiometry in the equation. Now what happens in the lab, we don't always get that amount. Okay, what we get in the lab is what we call the actual yield. This is the amount of product that is produced when we conduct the lab. Okay, you can think of them this way. Compare them to taking the test. Your theoretical yield is how much is that test worth? 100 points. Okay, your actual yield is kind of like your score. Well, I got a 95. I got an 85 out of 100. Okay, so percent yield is just a comparison of the actual yield to the theoretical yield. And there are a ratio between actual and theoretical. The equation that you need to know is this. Percent yield is equal to your actual yield divided by the theoretical times 100. Make sure you write this down. You're going to need to know this. You need to have this memorized. Okay, and your goal is for this to be 100%. Right? You got 100 out of 100 points. The lower you are, just like the lower you're on the test, the kind of the worse you do. Okay, or the worse results you're getting. So let's do a couple practice problems with this. First one, a copper metal is prepared in the lab by the reaction of 1.274 grams of copper 2 sulfate with zinc metal. A yield of 0.392 grams of copper is obtained. I would copy this down so you have it in your notes for practice. Okay, but they want to know what's the percent yield. So the first thing I have to be able to do is to write the chemical equation and balance it. Once I know that, then I can use stoichiometry to figure out what I should have got, because what I actually got was 0.392 grams. What I want to know is the percent yield. So let's work through this. Okay, the first thing we need to do is to write our equation. And we can see here it's a single replacement, so we make sure that zinc is more active than copper, which it is, and so we get this equation. It is balanced. So now what we need to do is, in theory, how much copper should we get out? So we said we start with 1.27 grams of copper sulfate. To get the copper, first thing we have to do is go grams of copper sulfate, copper 2 sulfate, to moles of it. So we know that 1 mole of copper 2 sulfate is equal to 159.61 grams. Now we have to go from moles of CuSO4 to moles of copper. Okay, so we use our molar ratios, our coefficients. So 1 mole of copper gives us 1 mole of CuSO4, and then finally we got to go from moles of Cu to grams of Cu using a periodic table, and we get 0.51 grams of copper is what we should have got. Now to figure out our percent yield, we take what we actually got, which is 0.392 grams, divide that by 0.51 grams, kind of like what you got on the test, what you should have got on the test, multiply it by 100, and we end up with a 76.86% yield. Not too bad, and when we do it in class, we try to get a 90% or better yield. That's what we consider successful. Below that, we may want to think about redoing our experiment. Alright, let's try another one here. Nitrogen dioxide can be converted to dinitrogen pentoxide by reacting it with ozone, O3, stuff in the air. This reaction will also produce oxygen. So part 1 says calculate the percent yield if 0.38 grams of nitrogen dioxide reacts and forms 0.36 grams of N2O5. And then part 2 says what mass of N2O5 will result from the reaction of 6 moles of NO2 if there is a 61% yield. So let's not worry about part 2 right now. Let's go to part 1. So we need to write an equation that says nitrogen dioxide, okay, when it reacts with O3, produces dinitrogen pentoxide and oxygen. So that equation looks something like this. NO2 plus O3 gives N2O5 plus O2. It's balanced. Now they want the percent yield of this. So we start with the information that we're given. Okay, we start with 0.38 grams of nitrogen dioxide. We need to convert that to moles. Use our periodic table and the formula weight to find that 1 mole weighs 46.05 grams. Okay, now we need to go from the moles of known to the moles of our unknown, which in this case is the dinitrogen pentoxide. So we use our prefixes, 2 moles of NO2 for 1 mole of N2O5. And finally then we need to go to grams of N2O5. So we use our periodic table, figure out the formula weight of 108.01. Then we multiply, right, 0.38 times 1 times 1 times 108.01 divided by 46.05 equals, divided by 2 equals, and we get an answer of 0.545 grams of N2O5. Now, that's what we should have got in theory. Now what we're going to do is compare to what we actually got to what we got in theory. So we got through this experiment 0.36 grams. We should have got 0.45 grams, so that gives us a percent yield of 80%. Hopefully you're following this. Okay, let's go to part 2. Part 2 says what mass of N2O5 will result from the reaction of 6 moles of NO2 if there was a 61.1% yield. So not the 80% that we saw in the previous part of this, but there's only 61%. Okay, we start the same way, okay, with our given that's 6 moles of NO2. Okay, now we go from moles of NO2 to moles of N2O5. Remember, that was a ratio of 1 mole of N2O5 to 2 moles of NO2. Okay, but it's asking for mass. Okay, so we got to go from moles to grams. So we use our formula weight there. Now, if we stopped here, that would be what we should have got in theory if we started with 6 moles. But it's telling us that we don't want the theory, we want the actual, but it says it's 61% efficient. Okay? It's kind of like saying, well, you got a 61% on a test. What's your points? So what we need to do here is to multiply this by the 61%, but put it in decimal form. Okay? And when we do that, we find out that if it's a 61.1% yield, we end up with 197.98 grams of N2O5. Alright, I have 2 problems I want you to do on your own. Pause the video here, write this down, do this problem, and when you have it finished, come back and check your work. No cheating. Do this on your own. Right. So the first thing you had to do was write the balance equation. Magnesium plus O2 gives us magnesium oxide. It's balanced. Now we start with what we're knowing, 5 grams of magnesium. Okay, go from grams to moles. Okay, now we got to convert from moles of known to moles of unknown. So we're going from moles of magnesium to moles of magnesium oxide, and it's a 2-to-2 ratio from our coefficients. And then we want to go from moles of magnesium oxide to grams of magnesium oxide using our formula weight, and we find that it has a theoretical of 8.29. That's what we should have got. But the problem told us that we got 7 grams out. Okay, we should have got 8.29. We can multiply this by 100 and find we got an 84.44% yield. So hopefully you got that as well. Let's go ahead and try one more problem here. It says 10 grams of sodium hydrogen carbonate reacts with hydrochloric acid, that's HCl, and forms sodium chloride, 5 grams of it, water, and carbon dioxide. So first thing we have to do is write a balanced equation, then figure out the percent yield. So we're going to have sodium hydrogen carbonate. Hydrogen carbonate, that sounds like a polyatomic to me. Don't forget those rules. Reacts with hydrochloric acid, HCl, to form sodium chloride, water, and carbon dioxide. So pause this, write that balanced chemical equation, and then figure out what the percent yield is, and then watch the rest of this video once you're done. Alright, so here is our correct balanced equations. Sodium hydrogen carbonate plus hydrochloric acid gives us sodium chloride, water, and carbon dioxide. So now we start with what we're given. We're given 10 grams of sodium hydrogen carbonate. First thing we do is convert that to moles. Okay, now we go from moles of known to moles of unknown. So we know that 1 mole of NaCl is equal to 1 mole of the sodium hydrogen carbonate. Now we need to go from moles of sodium chloride to grams. So use our formula weight. The moles are canceling and we're left with 6.96 grams. That's our theoretical yield. So they want to know the percent yield. That said we got 5 grams out. So we're going to take that divided by the 6.96 grams, multiply by 100, and we get a yield of 71.84%. Pretty simple. Alright guys, hopefully you are following along with this. If you are lost at all, go back and watch the video, or else come and see me before class. If you didn't copy down those examples, I suggest you rewind, go back and copy this, because when we're in class, you're going to want those examples on how to do these so you can do the worksheets. I like to think of percent yield as what did I get on my test. You know how to do that. You take what you got divided by what you should have got times by 100. Same thing with this percent yield. What did you get when you did the experiment? That's your actual yield divided by what you should have got, your theoretical yield, and you get that by using your chemical equation and stoichiometry, and then multiply it by 100. So if you're not understanding this, guys, watch the video again, copy down those examples so you'll have them in class, or else come in and see me and I'll be glad to help you. Until the next class, guys, take care. I'll talk to you later.